This is the gas loss unit. When speaking of gases, there are four different variables that must be considered because they affect each other. The first one is pressure. Pressure is a force per unit area and exerted by a gas and particles when they collide with the walls of the container. In other words, the more collisions you have with the side of the container, the greater the pressure. The less collisions with the side of the container, the less the pressure. The units that are used to measure pressure are atmospheres, which are abbreviated ATM, kilopascals, which is kPa, and millimeters of mercury. The second is volume. Volume is the space that matter occupies. Its measurements are in liters and milliliters. The third one is temperature. Temperature is the measure of the average kinetic energy. It must be measured in Kelvin. So if you have a value that's given to you in Celsius, you have to be able to convert it to Kelvin. In order to do that, you would add 273. If you're doing the reverse conversion, say Kelvin to Celsius, you would subtract 273. Here's an example. When dealing with temperature, if we convert negative 75 degrees Celsius to Kelvin, that means we would add 273, which gives us a value of 198 K. Absolute zero is the base for the Kelvin unit. When all matter stops movement, that is 0 Kelvin. The average temperature of space is about 2 to 3 Kelvin. So it's fairly cold as in terms of the 0 point. For Celsius, the 0 point is the freezing point of water. So that's a little bit of a difference. Kelvin uses the measure of the average kinetic energy when that is 0. That is absolute 0. The fourth and last variable that we'll look at is the moles, which is a measure of the amount of matter in a substance. The symbol for the mole is lowercase n. There are 5 different laws that will be used for this unit. The first is Dalton's law. It states that the total pressure, or PT, total pressure of a gas, is equal to the sum of all the partial pressures. Notice in this example that the pressure of the oxygen in one container when added to the pressure of the nitrogen in the other container is equal to the sum of both containers added together. The second law is Charles's law. Charles's law states that the volume and Kelvin temperature are directly proportional. That means if one goes up, the other one goes up. If one goes down, the other one goes down. Notice in this example that the more heat that is added, the more the volume of the gas. In Charles's law, we also have to be able to show that as a graph. Okay, so graphically speaking, it's going to have a positive slope. And we also have an equation, which is V1 divided by T1 is equal to V2 divided by T2. This is that proportional equation that you've seen before. You must be able to state the law in all 3 methods: directly proportional, graphically, and in terms of the equation. The third law is Boyle's law. Boyle's law states that the pressure and volume are inversely proportional. That means as one goes up, the other one goes down. Note in the example that the relationship between volume and pressure, as the volume decreases, the pressure increases. Notice there's the pressure increasing and the volume goes down. As in the other law, we also have to use a graph to be able to show this. In this case, we have a graph with a negative slope. We also have a formula, and our formula is going to be pressure 1 times volume 1 is equal to pressure 2 times volume 2. The fourth law is Avogadro's law. Avogadro's law states that the moles and volume are going to be directly proportional. That means as one increases, the other one will also increase. Notice in our example, for the very first one, if we have 2 moles, that's going to be the same thing as 20 liters, because 3 moles is 30 liters. So therefore, 45 liters is going to be the same thing as 4.5 moles. Not only do we have to be able to state Avogadro's law in terms of whether it's directly proportional, we also have to be able to use a graph. In the graph, notice that it is also a line with a positive slope. And the formula for Avogadro's law is going to be V1, which is volume 1, divided by N1, which is number of moles of 1, is equal to V2, which is volume 2, divided by N2. Avogadro's law is stated at STP, so standard temperature and pressure. We have to be able to keep the variables of temperature and pressure constant in order for this law to apply. This is 22.4 liters of any gas is equal to 1 mole at standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere. The fifth and last law is the ideal gas law, which is used when temperature and pressure are not constant. It is PV is equal to nRT. This law has a constant, which is R, the variable R, and it's going to have a different value depending on the pressure of the gas. So for example, if that value is going to be 0.0821 if the pressure of the gas is reported in atmospheres. Or it can be 8.31 if the pressure of gas is reported in kilopascals. And finally, it can be 62.4 if the pressure of the gas is reported in millimeters of mercury. Notice that all of the other variables, or all the other units with these numbers are exactly the same. The only thing that's different is the measurement of the pressure in different units. In summary, the variables that we're going to have are going to be pressure, which is measured in atmospheres, kilopascals, or millimeters of mercury. Volume, which is measured in liters or milliliters. Temperature, which it must be measured in Kelvin. And lastly, number of moles, which is the amount of substance which has to be, or has the value of N. Listed is a summary of the laws. In the next video, you will use these to solve different gas problems where the variables of pressure, volume, temperature, and number of moles can be varied.